Here, you should be doing this over the weekend. We'll do bronze in class Monday. You know the drill. Go ahead and do the warm-up. Alright, look over your answers, change anything where you see a blunder. Alright, day 2, systems of linear equations. Today we're going to solve systems of equations by substitution. And this is day number 2. Okay. So when solving systems of linear equations using substitution, if no equation has a variable that is isolated, then you need to isolate a variable before substituting. So you'll notice both of these do not have any variables by themselves. Our goal, if we want to use substitution, is to move something over so you just have one variable by itself. This top one, I could potentially divide everything by 2 and then move the variable so y is by itself, but there's a simpler way for the second equation. If I just move the 2y over, I will get x by itself. And for substituting, it does not matter if the x or y are isolated, because we could substitute either one to solve. So let's take this new guy. You know what, I should have written it. No, it's fine. So I have x minus 2y plus 13, or x equals negative 2y plus 13. And then I'm going to take negative 2x plus 2y equals 16 from here. And I want to substitute out the x for this chunk. So what I can do is replace anywhere I see an x with this part of the equation. That's going to become negative 2. This is negative 2 times x, so I'm going to put parentheses and then insert the chunk that x is equal to. X equals this part of the equation. This means multiply when it's next to parentheses, so this is meaning the same thing. Add 2y and equal 16. Okay, from this point on, we need to use distributive property and simplify this a little bit. It's going to be 4y plus 2y is 6y. Combine your like terms. Add 26. Six y will equal 42. We want y by itself. So y is equal to 7. Okay, well that's not my complete answer, because I know my answer is always written in x, y form. So I have my y value, but I want to find my x value. How do I do that? Well, we can take that y equals 7, and we're going to plug it in to one of the equations. You can use either one, it doesn't really matter. Let's go ahead and use the bottom one. So x plus 2 times 7 equals 13. X plus 14 equals 13. So x will equal -1. There's my final part of the equation. That is the solution. Alright, let's do another one. This time we'll notice one of these is easier to isolate, and it's the y right here. In problem 1 we isolated x, but right now I'm going to isolate the y. I'm going to move the 4x over. So this is going to become y equals 4x minus 13. Move this other guy over. We don't change anything. Okay, well this chunk is going to go sub for that y. This y is like, hey guys, I'm too tired, I can't do this anymore, I need help. And the 4x minus 13 is like, bro, I got your back. So we're going to go ahead and rewrite that then. So 5x stays the same, but wherever you see a y up here, you're going to replace it with 4x minus 13 equals 17. Okay, simplify. We're going to use distributive property. That means multiply everything on the inside of parentheses. Add 5x and 24x. Add 78. 29x equals 95. Oh boy. Is that gonna work? Times 29 times. Did I do something wrong? Yeah, I did. Did I? No. That's it. Negative 5x. Blunder. That would be 19x. Does that even help me though? No, let's try it. 19 maybe times 5. Yeah, that'll work. Okay. So x is equal to 5. We're okay. We would need to find the y because our answer is always written for solutions of systems as xy. We just found our x. Let's find the y. We can use either equation. We could even use this one when we isolated y. Let's use that since we're looking for y anyways. So y equals 4 times 5 minus 13. Y equals 20 minus 13. So y is equal to 7. That's it. And remember that when we did these on Thursday, what this point means is the point of intersection. It's always good to, as we dive more into the realm of algebra and solving, that we keep in mind what's actually happening behind the scenes. And it means that this is the crissy-crossy point. Okay, bronze will be done in class Monday. That is the way the cookie indeed crumbles. You have yourself a merry weekend. Or I guess Monday, if you're watching this Monday morning. Anyways, goodbye.